Hello and welcome. In this video, we're going to talk about how to divide polynomials. We're going to focus on using the method of long division, which ties back to what we learned when we were first dividing numbers in elementary school. And we're going to extend that further to a shorter method that works in a particular case called synthetic division and applications of that, including the remainder theorem. So let's go ahead and jump right in. So I actually want to start today talking about what we knew about long division a long time ago. And we know that we can divide numbers using this method here. And what we do is we ask ourselves, how many times does this number go into 6? And it doesn't. So how many times does 25 go into 60? And 25 goes into 60 twice. So on the top up here, we write a 2. We multiply 2 times 5 to get 10, and 2 times 2 to get 4 plus 1. 25 times 2 is 50. And then once we're here, what we do with these two numbers is we subtract them to get 10. And then we bring the next digit down, and we ask ourselves, how many times does 25 go into 102? Well, 25 goes into 100 4 times, which is 100, and then again we subtract. That's going to give us 2, and we bring the next number down. How many times does 25 go into 25? Once, which is 25, and then we bring the next number down. 25 doesn't go in to 7, so 7 is our remainder, and the way that we first wrote this in elementary school, I remember writing it as like 241 with a remainder of 7. But once we got a little further in math, we learned that we write that as 7 over the thing that we were dividing by, 25. So 25 goes into 60,257 times, 60,257, 241 and 7 over 25 times. So key things, just vocabulary reminders. This number on the inside is called the dividend. That's what we're dividing into. The number on the inside is called the dividend. Where that shows up in our fraction is in the numerator. I always learned that the top dog goes in the doghouse. So if it's written as a fraction, the top number goes on the inside of your division problem. And then the portion that we are dividing by is called the divisor. The divisor. So the polynomial divisor, in this case, is d of x. And the dividend, the thing that we're dividing into, is called the dividend. So when we do this, sometimes things divide evenly. Like if I just divided 25 into 6,257 right here, I would have gotten to stop, and I would have had something that divided evenly in. However, when we don't have something that divides evenly in, we have this remainder. And that's what's coming into play over here. So what we'll have as our answer is the quotient, whatever we got, plus the thing, that remainder. So we could also write this as 241 plus 7 over 25. So key things to remember. What is left over goes over the thing that we were dividing by, the divisor, which is the portion that's on the outside here. So we're going to extend this idea now to polynomials, and the good news is it works exactly the same way. You're going to ask yourself the same questions. You're going to use that same, what I like to refer to as the old school division line, this thing right here to divide. And we're going to multiply and subtract and bring terms down exactly the same way that we did before. So let's look at how this applies to polynomials. So what we're going to do here in this first example with polynomials is we are going to divide 2x cubed minus 3x squared plus 4x plus 5. That's going to be divided. So that's in the numerator of our fraction, which means it goes inside. That's going to be divided by our divisor, x plus 2. So first thing, we're just going to write it using that sort of old school division symbol with the dividend on the inside. So that's step 1. Step 2, you're going to ask yourself, what do I need to multiply this by to make it look like this? Really what I asked myself over here, I worded it differently, but what do I need to multiply 25 by to make it look as close to 60 as possible? And we said I need to multiply it by 2. Now we're going to ask ourselves, what do I need to multiply x by to make it 2x to the third, or as close to that as possible? Well, to get the 2 in front, I need to multiply by a 2. To get it to be x to the third, I already have 1x, so I need x squared more, so that when I combine those, I get 2x to the third. And just like we did over here, the next thing I'm going to do is I'm going to multiply that number by each part of my 25. So I'm going to multiply 2x squared by each part, each term of my x plus 2. So 2x squared times x is 2x to the third. 2x squared times 2 is 4x squared. And then, just like I did over here, the next thing I did was subtract. So then I'm going to subtract these two things. So we're subtracting this binomial, which means that this negative sign needs to distribute. So this is going to be 2x cubed minus 2x cubed, which is 0. That better be what happens, because that was the whole goal of picking 2x squared to be on the top. But I'm going to have negative 3x squared minus 4x squared. That's going to give me negative 7x squared. Then we're going to bring down the next term. And I actually like to bring down all of the terms. Otherwise, sometimes I forget that there was another term up there. So I'm going to just bring everything down, and I'm going to repeat that process again. So now I need x to look like negative 7x squared. So I need to multiply it by negative 7 to get the negative 7 in front. And to get x squared, I need to multiply it by x. So this is going to give me negative 7x squared, and then negative 7 times positive 2 is going to give me minus 14x. Again, remember, we're subtracting, so this is going to become minus a negative or plus, and this is going to become minus a negative or plus. Negative 7x squared in the red plus 7x squared in the green is 0. 4x plus 14x is going to give us 18x, and I'm going to bring my 5 down. How many times does x go into 18x, or what do I need to multiply x by to make it look like 18x? I need to multiply it by 18. That's going to give me 18x plus 36, because 18 times 2, right? 18 times x, 18 times 2. And then I'm going to subtract. 18x minus 18x is 0. 5 minus 36 is going to be negative 31. So here's my remainder, and here's how I write my remainder. It's going to be, I always write plus. The negative is going to go in the numerator, right? I'm saying plus the remainder over the divisor. So the remainder is 31. The divisor, the thing I was dividing by, is x plus 2. So when I divide those two polynomials, this is what I get. All right, let's practice that process on a couple more problems. All right, step 1 said write using old school division, aka the first term goes inside, top dog in the doghouse. So I'm going to start on the outside. I'm going to have the thing I'm dividing by, the divisor, x squared plus 3x plus 2. And on the inside, I'm going to have 2x to the fourth plus 3x to the third. Now, I notice I don't have an x squared term, so I'm actually going to write plus 0x squared. And the reason I do that is so that everything still is going to line up well when I'm doing this. Just like with multiplication, I like to have a placeholder if anything is missing. Plus 5x minus 1. So you don't have to have the 0x squared there. You're just going to have to be really careful not to incorrectly combine like terms if it's not there. So, top dog in the doghouse, everything's set up. I'm asking myself now, what do I need to multiply x squared by to make it look like 2x to the fourth? Well, I need a 2, and I need 2 more x's. So, 2x squared. And if I multiply that by each of these 3 terms, I'm going to get 2x to the fourth plus 6x cubed plus 4x squared. Then I'm going to subtract, so I'm going to change the sign on everything. That's going to give me 0 minus 3x cubed minus 4x squared, and I'm going to go ahead and bring down my 5x and my negative 1. Now I want you to pause the video and see if you can identify what number we need to multiply next, and just do the next step. Don't work all the way through, just do the next step. Then unpause the video and see how you did. All right. In order to get negative 3x cubed, I need to multiply by negative 3x. That's going to give me negative 3x cubed minus 9x squared minus 6x. And I'm subtracting, so I'm going to change the sign on everything. That's going to become 0 plus 5x squared plus 11x. And I'm going to bring the negative 1 down. Again, I encourage you to pause the video and see if you can finish this problem off. Make sure you write the remainder. All right, hopefully you had time to work through this. I need to multiply this by 5 to give me 5x squared plus 15x plus 10. And when I subtract, right, this is going to be minus, minus, minus. I'm going to get 11 minus 15 is negative 4x. Negative 1 minus 10 is negative 11. So there's my remainder. So I'm going to put plus negative 4x minus 11 over the thing I was dividing by, x squared plus 3x plus 2. Make sure that your division line covers that entire numerator and denominator when you're writing your final statement. And if you would like to rewrite your final statement down on the bottom, that's a great idea too. Okay, I'm going to encourage you to pause the video and try and work through number 2 on your own. Maybe do a step, unpause the video and see where it's at, and then keep working through, but really try on your own before we move on to a different kind of division. Okay, here's my setup step, and I did put zeros. Again, it's okay if you don't have them, just make sure that you're still lining everything up to combine like terms correctly. The first thing I need to multiply by is 4x squared. That's going to give me 4x to the 4th minus 12x cubed minus 8x squared. And when I subtract, that's going to give me 12x cubed plus 8x squared. And I'm going to bring down my next 2 terms. Again, I'm going to encourage you to pause the video and work through the next step on your own, and then unpause the video and see how you did. So I'm going to multiply by 12x. That's going to give me what I have in green. I'm going to change the sign since I'm subtracting. And that's going to become 8 plus 36, 44x squared, 24 plus 5, 29x, and I'm going to bring my negative 4 down. Again, pause the video, work through the last steps. Got to give myself a little bit more room here, so I'm going to need to multiply by 44. It's going to give me 44x squared. If I multiply 44 by 3, that's going to give me negative 132. X. 44 times 2 is 88. Then I'm subtracting each of these things, so that's going to give me 161x plus 84 as my remainder. And how do I write that remainder? 161x plus 84 over the thing I was dividing by, x squared minus 3x minus 2. Okay. Let's move on to a different kind of division besides long division, which will work in any case when we're dividing polynomials. Let's look at synthetic division. Synthetic division is great because it takes away a lot of the extra variables and just the pieces that make our work sometimes look messy, and it allows us to just focus on the coefficients in a totally different process that still is going to work for division. The key thing is, though, why don't we use synthetic division all the time? Because it doesn't work all the time. It only works when we're dividing a polynomial by a binomial of the form x minus k. So it doesn't always work, but when it does work, it's a great option. So the very first thing that you're going to do is you are going to write the coefficients of the dividend, the thing that you're dividing by. You're going to write the coefficients, so the numbers in front of each term, sort of in like an upside down, I'm going to call this an upside down looking division sign. So you're going to write each of those coefficients. Something really, really important to see here. If you are missing a degree, you need to put that coefficient as a 0. It's not optional for synthetic division. You're going to get the wrong answer if you don't have it as a 0. So negative x to the 3rd, the coefficient there is negative 1. 4x squared, the coefficient there is 4. We're missing a term that just has an x, so I need a 0. And then 9 is my last term. So step 1, write each of the coefficients out. Put a 0 anywhere that you're missing a term. The second step is you're going to write the divisor, the thing that you're dividing by. You're going to write it, you're going to think of it as a 0 that you're factoring out. So what makes this equal 0 if x is equal to 3? So I'm going to put the opposite on the outside. So a 3 would go on the outside. If we were doing x minus 2, a 2 would go on the outside. The next thing we're going to do is we're going to bring the first coefficient down. And I really do encourage you to write the arrows that I'm going to write here. Now what we do is we take our purple number, our 3, and we're going to multiply it by this number down here. We're going to multiply it by that 3 and rewrite that over here. So 3 times -1 is -3. Then we're going to add going up and down. So 4 plus -3 is going to be 1. Then we're going to do that same process again. 3 times 1 is 3, and then we're going to add up and down. 0 plus 3 is 3. 3 times 3 is 9, and then we're going to add going up and down. So 9 plus 9 is going to give us 18. So again, each of these numbers came from the coefficients. This number is the opposite of what we were dividing by because that's what the 0 is that we're dividing out. We brought our first number down. We multiply our 3 by our number here, and then we add up and down. Multiply by our number out there, 3, add up and down, multiply by 3, add up and down. What we were doing here is we're dividing something that is degree 3 by something that's degree 1, which means our answer, so I'm going to actually rewrite this, -x to the third plus 4x squared plus 9 divided by x minus 3, and this is how I want you to write your answers. This is going to be equal to, well, now these numbers down here are our coefficients again. They're going to be the coefficients, and we're going to go down 1 in degree. So it was x to the third. Now it's going to be -1x squared plus 1x plus 3. And this number over here is our remainder again. And we write our remainder in the same way that we did when we were doing long division. So plus 18 over the thing we were dividing by, which is x minus 3. So I want to keep this example here so we can kind of look back at that while we're working on a couple more problems using synthetic division. All right, here we go. Let's focus on the setup first. Upside down division symbol. Write the coefficients, -1x cubed, 3x squared, 1x. And notice there's no constant, so I need to have a 0 here. The opposite of what I see here is 2. That's what the 0 would be. I'm going to bring down my -1 and I'm going to multiply. -1 times 2 is -2. And then I'm going to add up and down. That gives me 1. 2 times 1 is 2. And then I'm going to add up and down. That's going to give me 3. 3 times 2 is 6. And I'm going to add up and down. That's going to give me 6. So when I have -x cubed plus 3x squared plus x, and I divide it by x minus 2, I'm going to go down a degree, so it was degree 3. Now it's going to be degree 2. -x squared plus x plus 3, and our remainder here is going to be plus 6 over x minus 2. All right, let's look at another one. All right, I want you to try and just do the setup part on number 5 with your coefficients and your little upside down division line, and then unpause the video and see how you did. All right, here's the setup. 3, -2, 2, and -5. There's no terms missing. -1 is going on the outside. We're going to bring our 3 down. Now I'm going to encourage you to pause the video and try and do just completing the long division, not actually rewriting your final answer. So go ahead and pause the video there. Hopefully you had time to pause the video. If I multiply, I get -3. If I add up and down, I get -5. If I multiply, I get +5. If I add up and down, I get 7. If I multiply, and again I'm multiplying by this number, I get -7, and if I add up and down, I get -12. Our final answer is going to be a degree 2 polynomial, so I'm going to rewrite this statement here. Yes, I do want you to rewrite exactly what we're doing so it's clear what our answer is. Now pause the video and see if you can write your degree 2 polynomial answer. All right, we should get 3x squared minus 5x plus 7 plus our remainder, negative 12 over x plus 1. Okay, I'm going to encourage you to do this last example of synthetic division on your own and then unpause the video and see how you did. First key thing, make sure you have a placeholder where there is a missing term, which in this case is the cubic term. Then we're going to bring our 3 down and do our multiplication and addition. Now I'm going to rewrite the original statement I was dividing with my answer, which is now going to be a degree 3 because this was a degree 4. And there I have my final answer with my remainder. We're going to do one more quick thing, which is we're going to talk about the remainder theorem and how we can actually use synthetic division to evaluate a polynomial out of value and how that can save us time. So we've already talked about how the remainder when we're dividing is that extra piece, and if we're using synthetic division, it's that last number over here at the end. The remainder theorem tells us that we can use synthetic division as a shortcut to evaluate a polynomial for a particular x value. What we do is we actually use the exact x value that we're being told to do. We work through synthetic division in the exact same way. But instead of the remainder, or instead of calling the remainder, that is that value. So this number right here will be the answer that we're looking for when we are evaluating. So what do I mean by that? If we are evaluating x equals negative 4, and we're going to use the remainder theorem, so we're going to set this up like synthetic division, I'm actually going to put negative 4, not the opposite, because I'm not given a factor. I'm basically being asked, what is f of negative 4? That's what we're being asked here. We're going to set the inside up the same way. 5 is our first coefficient, negative 1 is our second, then 13, then 29. And we're going to work through the synthetic division process the same way. So I'm going to bring 5 down. 5 times negative 4 is negative 20. If I add up and down, I get negative 21. 4 times negative 21 is negative 4 times negative 21 is positive 84, and if I add up and down, I get 97. If I multiply 4 by 97, or negative 4 by 97, I get negative 388, which if I add those 29 and negative 388 together, I get negative 359. So that is the value if I plugged this in. Let's actually confirm that that works. I'm going to ask you to pause the video in just a minute and actually plug in negative 4 to each of these places over here where there was an x. This is how we would have done this problem before today. And then simplify and see what you get. And we do, in fact, get the same thing. So on number 7, pause the video and set it up. Then unpause the video and make sure you set it up correctly. Be careful. Remember that if you have missing terms, they need to be zeros. So here's our setup. Remember, it needs to be positive 5 on the outside because we're evaluating, not dividing, and that we need to have a placeholder for the term that's missing. Go ahead and work through the synthetic division. Here we are, and instead of rewriting this as a polynomial, we're going to rewrite this by saying f of 5 equals 429. Now go ahead and plug 5 in and do it the old way using direct substitution. So we're here. 5 cubed is 125. 125 times 4 minus 50 minus 21. 4 times 125 is 500 minus 71. This is going to give us 429. Same answer. So this is a shortcut way that allows you to use the new concept that we're learning to help you with something that a lot of us have issues just plugging numbers in and simplifying. So let's talk about what we learned in this video. We talked about how to use long and synthetic division to divide two polynomials, how the top dog goes in the doghouse or the dividend goes inside, and we divide. The divisor is that denominator. We talked about how to write the remainder as the portion on the outside, the divisor, or whatever the remainder is over the divisor. We used both long and synthetic division to perform division, or to divide polynomials. And then we extended synthetic division with the remainder theorem to talk about how to evaluate a function using synthetic division. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.